Hi, this is a video showing how to graph logarithmic functions. Okay, let's take a look at the directions. Graph the function, find its domain, its range, and the equation of the asymptote. Okay, so here's the function. F of x equals the opposite, right? The opposite, oh, let me find my little marker here. Opposite of log base 3 of x of the quantity x plus 2 minus 1. So what we're going to do first off is look at the logarithmic function family, and we'll take a look at the general form, compare that to our function, and then identify some of the important components that will help and guide us to creating the graph and figuring out the range and domain and asymptotic line. So the general form goes like this: log base b, the quantity x minus h. Now pay attention to it. It has to be in the form of that minus sign. Plus k, and there has to be a plus. If we take a look at our function, we have the opposite of log base 3, the quantity x plus. Well, we have a plus here, not a minus. And plus 2 minus 1, and we have a minus here and not a plus. So we're going to have to rearrange this to make it fit the form. We'll say equals the opposite of log 3 x minus a minus 2, and then we're going to say plus, because we need to have a plus there, plus a minus 1. And look at how I use parentheses here, and that really helps us, because then it helps us just pull out h and k, right? So h is just going to be -2, and k is just going to be -1. And of course, b is the base, and so that is 3, right? There's the base right there. Okay. So now let's move on and take a look at the parent function and the graph of the parent function and how that behaves. And then we'll be able to use these values, h and k, to help us figure out how to translate the parent function to the general form. So here's the parent function, log base 2 of x, and it looks like this. It's that graph here, that line right there. And for reference though too, we also, let's take a look at the opposite of that, because this is what we're dealing with, right? We're dealing with the opposite of log. So, and look what happens. It reflects over a line, a horizontal line, and it just in this particular case, it just happens to be the x-axis, or y equals 0. Now pay attention to this line here, right? This. Can you tell me, can you think and tell what is the name of this line? Right, well, what is the name of this line? Well, one of the things we know is it's x equals 0. Whoa, to make this look like an x. Okay, out of control with my writing. But another name for it is the asymptotic line. It says asymptote. It's the place is imaginary line where the graph gets close to but never touches, right? And so that's pretty important. So for this one, it's x equals 0 for the parent function. Okay, and let's move on and take a look at the general form. So here we have the general form, and we have a function that's in blue, f of x log base 2 of x of the quantity x plus 2. So we know that h, like ours, equals -2. Well, what happened here? Well, here's for the parent function, we know that the asymptotic line is x equals 0, and for this function, what it did was when h equals -2, it moved it to the left 2 spaces. Right here, x equals -2 is the asymptotic line for the function that we're looking at in blue here. And likewise, we have a function here, log base 2 of x minus 1. And so this is going to be h equals 1, so it's a positive 1. What's it do is it pushes it from the parent function, it translates it 1 space over. So here we go here. If h is less than 0 or negative, the graph of the parent function is translated to the left. That makes sense, right? Intuitively, we know if something is negative, it goes to the left along the x-axis typically. If h is positive or greater than 0, it translates to the right. So that's how it goes to the left and right. Well, look at what k does. K pushes it up and down. So when k is positive, it pushes it up. When k is negative, it pushes it down. This is how the general form behaves in relationship to the parent function. Okay, now let's just take a look at straight ahead definitions. Straight ahead definitions say that the domain is the set of all real numbers greater than h. Greater than h. Well, we know what h is. We've defined it already as -2. So we can replace h in this sentence with -2, and we have the domain. The domain is a set of all real numbers greater than -2. Voila, look at that, straightforward, real easy. The asymptote is the line x equals h. Okay, so we again replace h with what we know to be h, which is -2, and we can say that the asymptote is the line x equals -2. Straightforward. Let's take a look at the last definition. The range is the set of all real numbers. Look at this. We just did 3 pieces of the answer. Now we have this information. We can work on the graph. To help us with the graph, what we'll do is set up a table. Table is always makes it easy and convenient to create a graph. If you have some points to work with, then it's a lot easier to plot it. So let's take a look at these 3 points. X equals -5/3. Another way of thinking this is 1 and 1/3, right? X equals 1 and x equals 7. So let's take a look at f of -5/3 equals the opposite of log 3, log base 3 of, well, what do we have? If we have -1/3 and a +2, that's just going to leave us, and we combine those, we're going to get 0.333, or 0.33. We'll just take it to 2 decimal places, right? Then we do f of 1, and that's equal to the opposite of log base 3 of, well, 1 plus 2 is 3, minus 1. F of 7 equals the opposite of log base 3, and 7 plus 2 is 9, minus 1. So use your graphing calculator, not your scientific calculator, to compute these values, okay? And what I do is I use this web 2.0 calc.com. I go there and I find that really handy, and that's the one I use. They have a help button. Press the help button to show you what to do. They have a video tutorial. Use that. It'll show you what to do also. But what happens is when we take these, when we evaluate this function at these points, we come up with f of x when x equals -5/3. We come up with f of x equals 0 when x equals 1, f of x equals -2, and when x equals 7, f of x equals -3. So we know that our asymptotic line is x equals -2, and that is labeled here. So we know that the function is not going to go beyond that point, right? And so let's just plot some points. X equals negative, what do we have? 1 1/3. Let's call that 1, so it's going to be about there. And then y, at that point, y equals 0. So let's get that, we'll call that good right there. When x equals 1, that's about right there. Y equals -2. These are increments of 2. So we'll call that right there. When x equals 7, 6, 7, y equals -3. That'll be right there. And you can see it shaping up. So the asymptotic line, now I'm going to try to draw this, but it's going to be a little bit funky. Whoa. Make the curve. Okay. And then it'll continue down through there. So it's a little bit sloppy, but so we'll take a look at a nice clean version of it. And because I definitely want to show this to you. So here is the line that we're taking a look at, right? Boom, and the asymptotic line there with x equals -2. And but I want to show you what it looks like when we don't do the opposite. And you can see that it reflected over the line y equals -1, because here they are. Here are both of the lines here. So, okay, we've come to the end. I hope you found this helpful. Bye.